In this video we will be looking at matrix multiplication. Two matrices can only be multiplied together if the number of columns in the first matrix is equal to the number of rows in the second matrix. In general, matrix multiplication is defined when the orders of the matrices follows this pattern. We have A times B is the order of the first matrix, where B is the number of columns, and then for the second matrix we have B times C, where the number of rows is the same as the number of columns in the first. So if that is the case for their orders, we know matrix multiplication is defined. The resultant matrix is of order A times C. So that comes from the number of rows of the first matrix and the number of columns of the second matrix. Gives the order of the resultant matrix. If multiplication is defined, we find that A times B does not equal B times A. There are, of course, some exceptions, and we'll see those in another video. Consider the following matrix multiplication. We can establish that this multiplication is in fact defined by checking the order of both matrices. So for the first matrix we have 1, 2 rows times 1, 2, 3 columns. And for the second matrix we have 1, 2, 3 rows by 1, 2 columns. So because the number of columns in the first is equal to the number of rows in the second, matrix multiplication is defined, and the order is given by 2 by 2, which is this matrix here. So that is a 2 by 2 square matrix, which is the resultant matrix. When we multiply matrices, we take the ith row of the first matrix and we multiply it by the jth column of the second matrix. The result of this process occupies the xij position of the resultant matrix. So in general, we can see that when we multiply out these matrices, what we do is we take A11 and we multiply it by B11 to get the first part of this entry here. In the same entry, we take A12 and we multiply it by B21, and that gives the second part of this entry. So we add up each of these individual multiplications to find the first entry. Then we continue and we take A13 and multiply it by B31 to get the next part of this entry. Then we add all of those up, and that gives us one individual entry in the position x11 of the resultant matrix. And as we continue this process, we get the other entries in the resultant matrix, which we'll see in a few examples in a moment. So for our first example, we want to evaluate the matrix -2, 5 multiplied by 10, 1, 3, 4. So before we go too far, we want to check that the matrix multiplication is defined. So the order of the first matrix is 1 row by 2 columns, and then the matrix of the second one is a square 2 rows by 2 columns. So once again, the number of columns of the first is equal to the number of rows of the second. So that means that the matrix multiplication is defined, and we know that the resultant matrix should be of order 1 times 2. So our job now is to find what the result of this matrix multiplication is. So the first thing we do is we take the first row of our first matrix, which is -2 and 5, and we multiply the -2 by 10 and the 5 times the 3. So the first entry will be -2 times 10 plus 5 times 3. We then repeat that to get our next entry. So our next entry is going to be -2 times 1 and 5 times 4. So we have -2 times 1 plus 5 times 4. So that is going to equal, and in the blue we have -20 plus 15, and in the green we have -2 plus 20, and when we evaluate that, we find that that is equal to -20 plus 15 is -5, and -2 plus 20 is 18. So that there is the resultant matrix, and it is of order 1 row by 2 columns, which is what we found back up here. In this example, we're going to evaluate the matrix multiplication as shown. So the first thing we need to do is determine what the orders of the two matrices are. So for the first matrix, we have 1, 2 rows by 1, 2, 3 columns. And for the second matrix, we can see there are 1, 2, 3 rows by one column. So because the number of columns in the first matrix is equal to the number of rows in the second matrix, it means that the multiplication is defined. So that means we can evaluate this matrix product. We can also determine what the order of the resultant matrix will be by having a look at these two numbers here. So this tells us that the result matrix will be 2 by 1, which is 2 rows and 1 column. So now our job is to actually evaluate this. So the first entry is found by taking the first row and multiplying it by the first column of the second matrix. So we multiply 3 by 1, we multiply 1 by 2, and we multiply -2 by 5. So we have 3 times 1 plus 1 by 2 plus -2 times 5. Next, we multiply the second row by the first column. So we're going to have 2 times 1, 4 times 2, and 0 times 5. So that is 2 times 1 plus 4 times 2 plus 0 times 5. So now we just need to simplify that down. So for the first entry, 3 times 1 is 3 plus 2 minus 10. And the second entry is 2 times 1 is 2 plus 8 plus 0. And then when we calculate that, we find 3 plus 2 is 5 minus 10 gives -5 as the first entry, and 2 plus 8 plus 0 is 10 as the second entry. So that is the resultant matrix for the product shown above. In this example, we want to evaluate the following matrix product. So the first thing we need to do is decide whether the matrix multiplication is defined. And to do that, we need to work out the order of these two matrices. So the first matrix has 2 rows and 2 columns, making it a 2 times 2 square matrix. The second matrix is also a 2 times 2 square matrix, which means that the number of columns in the first matrix is equal to the number of rows in the second matrix. So that means that matrix multiplication is defined. Next, we can inspect these two numbers here to determine the order of the resulting matrix. So we're going to get a 2 times 2 square matrix as the matrix product that comes out once we've evaluated this. Now our job is to find the actual answer to this question. So we start off by taking the first row of the first matrix and multiplying it by the first column of the second matrix. So we're going to have -1 times 6 and 2 times 9. So we have -1 times 6 plus 2 times 9 as the first entry in the resultant matrix. So the next step is to take the first row again and multiply it by the second column. So we're going to have -1 times 1 and 2 times -8. So that goes in this position here, which is -1 times 1 plus 2 times -8. Now that we've multiplied the first row by all of the columns in the second matrix, we take the second row of our first matrix and multiply it by all of the columns. So we're going to have 4 times 6 and 0 times 9. So that will go in this position. So we have 4 times 6 plus 0 times 9. Finally, we take our second row and multiply it by the second column. So we have 4 times 1 and 0 times -8. So 4 times 1 plus 0 times -8. So we keep simplifying this down, and our first entry in blue becomes -6 plus 18. The second entry in green becomes -1 minus 16. And for the entry in orange, we have 24 plus 0. And in the purple, we have 4 times 1 is 4 plus 0 times -8 is just 0. So if we evaluate each of those entries, -6 plus 18 gives +12, -1 subtract 16 gives -17, 24 plus 0 is 24, and 4 plus 0 is 4. So that is the answer to this matrix product. So after this video, you should be able to understand when matrix multiplication is defined, determine the order of the resultant matrix when multiplying matrices together, and you should be able to evaluate the product of matrix multiplication.